So for this section, oil and gas, scanning with the medium range scanners again. This valve housing is a really cool application. And the reason why this one, it looks like a super simple part, and it is, but the approach to modeling it is what's novel, just like the last one, right? The approach to modeling it was fitting a mesh on the last one, fitting a mesh fit, and then doing a boundary fit on top of it. Now this one here is, you see that we need to model the external and internal. So with scan data, this is another example where you scan this project. They scan the entire external of the part. They cut it down the middle apart, and then you scan the internal. And then when you scan the internal, you scan the internal and external at the same time, right? So then you piece all of the scan data back together, and then I separate the scan data out from the internal scan data out from the external. So now we'll jump over to the model here in a second, but that way I can model these as positives from the inside. So let's go ahead and click over, and we'll walk through some of that. So here is the external. And then if you toggle that off, you see here's an internal, and then the cartridge section as well. So the cartridge, if we just turn that, we just have that as its own. And the reason why we separated that is because we're just looking for this. You could have deleted this as well, but. So now you'll notice that when we model this, we can model these pieces as positives instead of trying to surface the interior of the mesh. So we'll go ahead and roll back here. So we created that, we created regions, and we roll back in history here. And we'll just see the approach here. So first we extruded and created the easy stuff here, each side. So this, and then we mirrored across to that, and then we extrude the top and the bottoms as basic extrusions to create those. And then we build our brackets and stuff, and then revolve this guy, and then Boolean everything together. So there's your external. I believe that's everything. Now, roll forward. Oh, we got some other little things here going on. Roll forward. Cutting some of the holes away and the flange mounts there. So still on the external here, and we'll just jump forward here, and then we'll see where we end up there. Oh yeah, we have this little piece too. All right, so now we'll just roll back here. So the first thing, I went a little too far there. First thing they did is on the internal, turn the scan on, turn the small side on. So it looks like it's generally a revolve there. So then do your revolve, your trims in multiple directions. So trimming here, trimming there, cutting away there, and then your fillets. I think those are all the fillets. Yep. So you just modeled that as a positive like we were talking about before, and then cut that away from here. So a real quick way that we can see what happened there is you can come over, if we covered this in another one, is you can come over to View Clip and you can move back. Oops. Let's turn that on and off again. And you could always switch to inside box. And honestly, I like using it that way anyway. And you could turn this on and look at it this way to see how we cut that away to see the internal. So I fast forwarded past this one, but it's the same exact steps as this one, just cutting slightly different. And you see here, then we go ahead and cut away the center revolution of the cartridge of the valve and your top and bottom, so you see how it all comes together. So we essentially modeled it as three pieces: the exterior, one side, and the other side. And then we just cut this through the exterior at the end to create this guy. So that is an overview of how we did this concept. This is a combination of the skill here is scanning the exterior of a valve, knowing that it has lots of interior components to it. They cut it in half with a bandsaw apart or whatever, right? Scan the interior and then the interior and exterior of each side, and then put it all together as scan data, and then separate the interior pieces of the scan data into their own components from the exterior using all the hole fill and all the crazy mesh tools that we have inside of Design X, and then reverse engineering it, which honestly, it seems like that whole process sounds like it's a long time. It really doesn't take that long to do. This process, I did this one. This one was one that I did many years ago, and I'm pretty sure that it really only took me like 2 hours total. I didn't do the scanning though. Somebody gave me the scans, so that's not counting that part of it.